Hi, hello everyone. My name is Karthik Brahmanpalli and this is my capstone presentation for the ASANTe platform. And I'm working under the mentorship of Camelia Fauzi and Shajid. Let's get started. So, short introduction about our company. So, ASANTe is a purpose-driven commerce platform that connects local businesses with non-profits and social causes. So, when a business joins ASANTe, they choose the cause they care about: climate, advocacy, education, animal welfare, and the platform matches them with the right non-profits. So, my role was build the analytics layer and then the infrastructure that tracks how businesses move through registration, where they drop off, and how we act on the data. Here's the full picture. Before we go into the detail, this is a brief pipeline of the project. So the pipeline have 5 stages. So the React registration front end captures user interactions and send them to a gRPC analytics service. So that service writes events into the Postgres analytics schema, which is a shared Asante DB package, and a fast API backend then queries the data and serves it to the React Analytics dashboard, which is where all the insights live. So the journey is simple. A business interacts with the registration flow. That event is captured, stored, queried, and surfaced as an insight on the dashboard. Everything is independently runnable. The dashboard works with the mock data even before the gRPC service is live. So this is the registration flow. The registration flow has 6 steps. Every business must complete sign up, verification, first login, cost selection, size, and entity information. So not everyone makes it through all 6 stages. So some get stuck and some get abandoned. Some abandon the middle of the registration flow. So that is what we needed to track actually. Coming to the data description, how the data is stored. The database has two schemas: the public schema, which stores the complete outcome of the data, things like app users, business profiles, cost preferences, and location data. So this is the permanent record of who registered and then comes the analytics schema, which we have to work on. That is the main schema. So it captures the behavioral journey. It tracks every session, every step entry and exit, every cursor interaction, and every page view. The key tables are visitors, registration session, registration step, event, interaction event, and page session context. So the main thing in here is I focused on the analytics schema is to specifically what we can surface from it through the dashboard. So this is the schema verified in the PG admin after migration, all tables, columns, and indexes that are created correctly across both schemas. So now coming to the dashboard. This is the main thing that I have been working on and I have worked on. So the registration health dashboard, this is what I want to spend time on because it is the most visible output of everything in the analytics schema. The dashboard is a React app with 4 pages accessible through tabs at the top. So let me walk through each one. The home page is the operational page, the one you check every morning. It has 4 panels. Panel A, the headline summary, total sessions completed, how many are in progress right now, how many are stalled, and how many have abandoned. At a glance, you can see if the registration funnel is healthy or broken. And the panel B. So in the panel B is the stuck session table, and this is the most useful panel in the entire dashboard. It shows every active and stalled session in the real time, stored by how long they have been sitting on the same step. So if someone has been on the entity information step for 34 minutes, you see that immediately. There is a filter controller so that you can narrow by status, active or stalled, by which specific step they are on, and sort by time, step, total time inflow, and number of items. And then the panel C is the step friction summary. So it's a table showing all 6 registration steps with how many people entered each one, how many completed it, the drop off percentage, and the median of the P90 time spent. So, and any step with the drop off above 8% gets a red flag. So, any step with the P90 above 7 minutes gets an amber flag. You can immediately see which step are the biggest problems. And then the panel D, which is the abandonment email queue. It shows every incomplete session that has been idle for more than 24 hours and has a known email address, but it doesn't just list who to email. So it generates a step aware email template for each person. If someone abandoned at the verification step, the template tells them how to resend the code. If they stopped at the size step, it tells them not to overthink it, and then they can update it later. The database state alone with driving that personalization, no extra logic needed. You can toggle between pending emails and all emails and export the entire queue as a CSV with one click. Beyond the home page, there is a three analytic tabs that give the broader view. The overview tab shows 30-day registration trend, started versus completed sessions over time. So you can spot if the gap is widening or narrowing. It also has an acquisition channel quality matrix showing which channels like organic, Google, or Instagram bring the most sessions and which actually convert. And there's a registration activity heap map, uh, 7 by 24 grid, showing what time of the day and day of week people start registrations. That revealed that Tuesday and Wednesday mornings are the peak window, which is directly useful for scheduling follow-up emails. The registration funnel tab shows the full 6-step funnel as visual progress bars. Uh, a drop-off rate chart with threshold line and a page view table from the analytics schema showing average time on each route with OK or slow badges. And the UX behavior tab pulls from the cursor event data showing rage clicks per step, which tells you where users are frustrated, and the full cursor event spectrum covering hovers, double clicks, drag events, and position samples. Everything across all four tabs can be exported as CSV, three separate files covering step, friction, active sessions, and abandonment queue. A few things that genuinely surprised me during this project are: so exit type inference. The gRPC server determines whether a user went forward, went back, or abandoned purely by comparing step order numbers. So the front end passes nothing, the server figures it out. And the rage click detection. So the three or more rapid clicks on the same element within 500 milliseconds is measurable frustration signal. Mapped to registration steps, it shows exactly which UI is confusing users without any user feedback. And the dashboard being the first cross schema consumer, the first code to simultaneously read from the teammates table and mine, and seeing it actually work was the moment that made the whole architecture feel real. So this is my personal experience in the overall projects. Let's just say these are the checkpoints. So checkpoint one was about getting up to speed, understanding the project requirements, going through the existing code base and what had already been built. So understanding schema boundaries and then jumping straight into designing the schema. Then the checkpoint 2 was analytic schema design, figuring out what tables were needed, what the registration flow actually captures at each step, and how all of that maps into rows and columns. That meant thinking through visitor tracking, session management, step events, interaction events, and device context before writing a single line of code. And then the next checkpoint was the gRPC services, 7 RPCs across analytics proto, handling session management, exit type inference from step order, and attempt counting, all server side without the front end needing to pass any of that context explicitly. And the fourth checkpoint was dashboard and fast API backend. The four panel homepage, the four analytic tabs, real SQL queries, CSV export, and the filter and sort controls on panel B. And the final checkpoint was refinement and deployment. And then the technologies which we have used is the Python gRPC with protobuf for analytic services, React with white and recharts for dashboard, Postgres SQL with SQL Alchemy for the database, Fast API for the backend API, Docker for the database container, and pgadmin for verification. So To close, I built a dashboard for ASANTE's registration flow, which is a 4-tab dashboard to surface actionable insights. The goal was always four questions: how many people are completing registration, where are they getting stuck, how long is it taking, and who needs to follow up. So that was completed by creating the dashboard. Thank you for watching.